This is Euclid Book 1, Proposition number 42, Part 2. Yeah, I'm sure you're sitting there going, man, I gotta go through a Part 2? Yes, you do. The next thing you're going to do is you're going to use Euclid Book 1, Proposition number 23, and you're going to duplicate this angle here, right down here. That's right, angle FEC is going to be the same size as angle D. And you're going to use Euclid Book 1, Proposition number 23 to get it done. Now, once you get this angle here, you're going to have a line that's going to go from E to F. But you don't know exactly where F is going to be. And that's because you've got to draw a line that is parallel to line BC up here. And it's going to be called AG. Alright? So how do you draw this line? Well, that goes back to Euclid Book 1, Proposition number 31. So basically what you're going to do is you're going to have a triangle. Going to draw a little dotted line right down here from F to C. And what you're going to do is you're going to say this length right here, EC, is going to be up here. And the length of CF is going to be down here. And when you strike your arcs, it'll land right here. Okay? And so therefore you'll have your parallel line right here. Now, once you have your line that is parallel here, and you have your angle right here, then all you have to do is join point C with point G. And when you do, now you say, well, how do we know where point G is? Well, because you're going to duplicate this length right here, right up here. This length here is the same as this length here. So, when you draw a line from C to G, then these two lines become the same length, and they're both parallel. So now you have a parallelogram, FECG. Okay, so you've got, first of all, AG parallel to EC because of Euclid Book 1, Proposition number 31. And then you have a line CG, and it's parallel to EF because of, again, Euclid Book 1, Proposition number 31. Now, we need to go directly into the proof at this point. Alright, so, what was the first thing that Euclid proved? Well, he said that BE, this is BE, and EC are exactly the same length. And this is because of Euclid Book 1, Proposition number 9. BE and EC are the same length. And then he says that because this whole thing was bisected, ABE is exactly the same size as AEC. These two triangles are exactly the same size. And this is because of Euclid Book 1, Proposition number 38. So, triangle ABC is twice the size of triangle AEC. Okay? Now, we can then go on to say that by Euclid Book 1, Proposition number 41, parallelogram FECG is twice the size of AEC. Okay? So, if FECG is twice the size of AEG and AEG is half the size of ABC, then by the transitive property, the area of ABC is exactly the same as the area of FECG. And that is almost everything Euclid was trying to prove. So now not only can you say that parallelogram FECG is exactly the same size area-wise as ABC, but on top of all of that, you can say that FECG contains the angle D, because D was FEC. Okay? So D is equal to FEC, and so therefore FECG contains the angle D. And that's all he was trying to prove, folks. I'll tell you more in a future video, so stay tuned.